Radicals. The symbol is the radical symbol. The number under the radical is called the radicand. And this n is called the index. This is read as the nth root of x. N, the index, is always a natural number bigger than 1. When no index is indicated, we read this as the principal square root of x. If n is not stated, then n is equal to 2 automatically. Try these, and then when you have finished, we'll take them up. The principal square root of 25 is equal to 5, and 5 only, not negative 5. The square root of negative 25 is not a real number. We cannot have two identical factors that multiply to negative 25. The cube root of 27 is equal to 3. The cube root of negative 27 is equal to negative 3. There's no problem having a negative radicand when the index is odd. The fourth root of 16 is equal to 2. The fourth root of negative 16, again, it's not a real number. So whenever we have an even root of a negative number, that number is not real. So the root of negative 4 is not a real number. Radical rules, and actually they are based on the exponent rules that we've learned previously. Root a times root b is equal to the root of ab. And just to go back to our rational exponent rules, a to the 1/2 times b to the 1/2. We've discussed in class that when the exponents are the same, we can multiply the bases together. So a to the 1/2 times b to the 1/2 is equal to a times b to the exponent 1/2. So as an example, root 5 times root 7 is the same as the root of 5 times 7 is equal to the root of 35. The root of a over the root of b is equal to the root of a over b. And please notice these restrictions. These apply to only when the radicand is 0 or greater, and that is if the index is an even number. And we can elaborate on that in class. b must be greater than 0, otherwise this expression would be undefined. Try these two examples, and when you are done, let's see how you've done. So this means 2 times 6 is equal to 12, and root 7 times 3 is root 21. Root 6 times root 6, straight away you should be able to tell me that that is 6. Alternatively, you could say that it is equal to the root of 36, which is equal to 6. In general, root a times root a is equal to a, by definition. When we change from an entire radical to a mixed radical in simplest form, we want to take the root of 48 and express it now as a mixed radical. And there are two approaches to this. I will go over it again. If we want to, first of all, prime factor 48, 2 goes into 48, remainder 24, another 2, remainder 12, another 2, remainder 6, another 2, remainder 3, and finally 3, remainder 1. So the root of 48 is equal to the square root of 2 times 2 times 2 times 2 times 3, and for every pair of factors, its square root is that factor. So the square root of 2 times 2 is 2. Square root of 2 times 2 again is another 2. That's 2 times 2 is equal to 4, which is equal to 4 root 3. Now, a little bit more sophisticated way, if we know the highest perfect square that divides into 48 is 16, we can write it like this, as the root of 16 times 3, and the root of 16 is equal to 4. The 3 stays under the radical sign. You can try 250 on your own. I'm going to do this the more sophisticated way. So that's going to be, I know that 25 is the highest perfect square that goes into 250. That's 25 times 10, which is equal to 5 root 10. Now if you wanted, you could have prime factored this. I'm not going to do that right now. But if we want to change from a mixed to entire, well, 4 times root 3, the 4 came from the square root of 16, so it comes from 4 squared times 3 equals the root of 48. Simplify this. You can stop the video and see how you've done. 2 times 5 times 3 is equal to 30. And then under the radical, look what I'm going to do. I have the 3, from the root 3, root 2. I'm going to prime factor the 6, which is another 2 times 3. And I'm going to prime factor the 10, which is 2 times 5. Now if I want to just write this down a little bit neater, I'm going to put these factors in order. So we have 30 radical 2 times 2 times 2 times 3 times 3 times 5. I have a pair of factors, another pair of factors. The square root of 2 times 2 is 2. The square root of 3 times 3 is 3. So it will be 30 times 6. And we have a 2 times 5 stays under the radical sign. We have 180 root 10. For addition and subtraction of radicals, the principle here is that the radicands must be the same. So right now we can't do anything with this expression, but we're going to now rewrite it in a way, we'll see that what we can do with it. So the highest perfect square that goes to 50 is 25, so that the root of 50 is the same as the root of 25 times 2, minus, and the square root of 72, well, I know that 36 goes into 72. It's going to be at 36 times 2. Square root of 25 is 5, with the 2 staying under the radical sign, minus 6, which is the square root of 36, root 2. Now we have 5 root 2 minus 6 root 2. That gives us negative 1 root 2 or negative root 2. Why don't you try this next question on your own, and you can check to see how you've done when you're finished. So we have 5 radical 25 times 3 minus 3. Now the root of 128, I know that 64 goes into 128, so that's going to be 64 times 2 plus 2 times, I know that 100 is the largest square that goes into 300, 100 times 3 minus 2 radical, and I know that 49 is the largest perfect square that goes into 98. When we take the square root of 25, it's a 5, it's times 5, not plus. So it's a 5 times 5, it's going to be a 25 radical 3 minus square root of 64 is an 8. 8 times 3 is 24 root 2 plus square root of 100 is 10 times 2 is 20 root 3, and minus, over here we have the square root of 49 is 7 times 2 is 14, it's minus 14 root 2. I look at all of these expressions, I look for my like terms, which consist of those numbers that have the same radicand. So we have same radicand here and same radicand here. I'm going to start with the 3's. 25 root 3 plus 20 root 3 is equal to 45 root 3, and minus 24 root 2 minus 14 root 2 is minus 38 root 2. If you have further questions, we'll take them up tomorrow. This is the end of the video.